Welcome to a Wonder Junkie podcast. I'm your host, Ryan Anderson.
Nobody knows what's going on. Nobody knows. Nobody has the faintest idea. The best guesses are lies. You may be sure of it.
All right, Gerald, thank you so much for joining me this morning. I appreciate you.
Well, I'm thrilled and delighted.
Yeah, me too. I've been really enjoying your work, the fourth phase of water, and I feel like a lot of people who are going to listen to this will probably be exposed to your work for the first time. So it'll be nice to explore your ideas and find out what some of the belief system shifts they can make and what are the implications of your work and things of that nature. So yeah, let's explore water together.
Happy to share.
Yeah, so it sounded to me, I've heard you speak about this, but you discovered some of your work from Gilbert Ling initially, and that's what led you down this rabbit hole?
Rabbit hole. Well, that's one way of putting it. Yeah, Gilbert Ling, a hero of mine who unfortunately passed a few years ago. And Gilbert Ling, in many ways, a distinguished scientist. You know, it was after World War II, in 1948, that the Chinese government decided to send some scholars to the U.S. to further their studies and such. And there were four of them, and three of them won Nobel Prizes, and Gilbert Ling was the fourth one. He failed to win a Nobel Prize, and I think in my view, he should have won two Nobel Prizes. One for his work on water, and another for inventing the micro electrode, which people then used to probe the electrical potential of cells, which couldn't be done before then. And so many people have used it and gone on to win their own Nobel Prizes. Anyway, I first met him at a conference in Hungary. It was a conference to commemorate the work of a Hungarian scientist, a well-known scientist, whose interests was twofold. He was interested in muscle contraction and water, and he was a kind of maverick. He didn't agree with accepted views. So I was invited. At the time, I was studying muscles and how muscles contract, and I was invited to talk about muscles, and so of course I did. And I'm not sure. I think it was reasonably well received. But then I heard Gilbert Ling, and it was my first exposure to his work on water. And he was proposing a hypothesis, which I found really intriguing. He said that the water inside the cell was not like liquid water. You know, liquid water, the molecules are bouncing around fiercely and randomly and such. No. Inside the cell, the molecules are organized like soldiers at attention. And this was new for me, but it was interesting. And he not only presented his ideas, but he also presented mounds of evidence in support of his ideas. And then came some other speakers who presented more evidence in favor of Gilbert Ling's ideas. So I was intrigued, but I'm easily intrigued. So I didn't trust myself, and I went home and I decided to expose his ideas to several of my students, which I did. And it was one of the books. By that time, Gilbert had written, I think, 3 or 4 books, and I gave one of my books to a few of the students. And they came back and they said, this is amazing. If Gilbert Ling, if his ideas are right, then all of biological understanding is wrong. Why is it wrong? It's wrong because the assumption is that the cells are filled with liquid water, and behavior in liquid water is much different from behavior in a situation where the water is like a liquid crystal. And they said not only that it was so interesting, but also that it looks like he's right because there's a lot of evidence. And, I trusted these students more than I trust myself. and so my initial intrigue was supported by these students, and you know, I just had to get involved in some way because this was too important. You know, muscles are important, and I had been thinking that we made a substantial contribution to the field, but this was more interesting. I didn't know exactly where to start. We had no money to study study water. We had money only to study muscles, and yeah, but you know, muscles are mostly water. Even though people who theorize about muscle contraction ignore the water, as though muscles, the muscle proteins and such, operate in a vacuum, which you know has got to give the wrong answer because water's there, you know, and you got to take account of it. So what I did was to write a book because the book didn't involve grant money and such. And the book, the first half of the book, was an attempt to describe what Gilbert Ling had come up with in terms that I would hope that people could understand. Because Gilbert Ling, you know, brilliant as he was, I kind of assumed that everybody was equally brilliant and that reading through one of his books should be a no-brainer. But I think what he did was sat down at the word processor or the typewriter before that, batted out something, sent it off to the publisher, and the publisher would publish it. And the idea or the concept of editing, I edit hugely in my own books. I think editing may be a word that's missing from the Chinese language. I'm not sure. So to read Gilbert Ling's books is a real challenge. I must say, um, and so I decided to present Gilbert Ling's ideas in somewhat simplified forms, but in a form that you know people really could understand. And I'm not sure if I succeeded. The reviews of the the reviews were mixed. Some said, "Oh, you know, this is more of Gilbert Ling. Everybody knows that Gilbert Ling is a crackpot. Pay no attention to this book." At the other end of the scale was a cell biologist from Harvard, and you know, if he's from Harvard, you got to pay attention to it. And he said, "This is a 304-page preface to the future of cell biology." That one had more appeal. But anyway, that was the first half of the book, and the second half of the book um, uh, began with Gilbert Ling's ideas and explained how, in my view, and I think based on reasonable evidence, how cells could actually work. You know, if you have a liquid crystal, it's kind of like ice. Nothing can happen in it. So there needs to be a transition from that to something else where things can happen. And I documented that for half dozen different important cell types, that was exactly what the evidence showed actually happened. So the idea, you start with some kind of what he calls structured water, and with the trigger, it underwent transition to ordinary liquid water where things could happen, and then back again to structure. And the energy actually came from the structure. So um, so that, and then, you know, I was so curious to do experimental work, and we started doing experimental work. I was able to get some money, hire some people, and we began exploring Gilbert Ling's ideas, essentially, largely, in an effort to confirm what other evidence seen. And we confirmed some of what he found, and we found some other features that I think are equally or even more important than what Gilbert had found. And so uh, we found um, several things. I guess it's best to describe by describing what the experiment that we did, the essential experiment. So So we were looking for a liquid crystal formation, and crystals, pure crystals, if they start with a liquid of some sort, um, and the liquid has some contaminants, the contaminants will all be excluded, because to get a pure crystal from something that's contaminated, you got to get rid of the contaminants. So we constructed a little chamber, and we put a gel into the chamber. We suspected that the gel could be an important nucleator of growth of this, and in the chamber was water, and some little particles called microspheres, little tiny spheres that were suspended in the water. And our idea was, if there's a region somewhere of ordered water, crystalline, liquid crystalline like water, it would push out those microspheres. And without any delay, it was practically immediate. We found it, and it was beyond our imagination, and because of the size, it was a huge region. And we began to see it not only with one gel, but other gels, and we began to see it with polymers of various sort, with biological agents. All that was necessary was that they be hydrophilic, or water loving, so to speak, and most substances are. So we found this giant region of exclusion, and someone said you should give it a name. So we called it Exclusion Zone, or EZ for short. And it works really well because it's easy to remember, but it doesn't work in Europe because it's EZ in Europe. So, you can't have everything. And okay, so we found this region, and then out of curiosity, because I had experience in the past with Gilbert Ling's microelectrodes. And so I thought, well, let's stick a microelectrode in and see. And we anticipated that it would be neutral, as Gilbert Ling's ideas would surmise. But we were shocked, so to speak, by electrical. We found it's negatively charged. And that didn't make sense, because if you start with water, water is neutral. And so how is it possible that neutral could transition into something with net negative charge? A lot of head scratching. You can see I'm missing a lot. Um, and that we found soon after that there was indeed positive charge, and the positive charge was existed just beyond the region of negative charge. So you got a negative zone, the EZ, next to a positive zone, which is basically water plus protons, or hydronium ions, as they're known, because positive charges stick to water. They have a tendency to do that. So you got negative exclusion zone, which later we called fourth phase water, because all the properties of this zone that we measured, none of them were the same as ordinary liquid water. So EZ, or fourth phase, negatively charged in one region, not always, but in most cases, negatively charged, and a region of positive charge. Well, everybody knows that if you got negative next to positive, you got a battery. Um, and we found in experiments later that I can talk about, if we get to it, we could demonstrate that this electrical energy was used in biology and beyond biology. And we demonstrated proof of principle that if you put one electrode in the negative and one electrode in the positive, you can obtain electrical current to light a LED lamp, for example. So there isn't really much doubt about this. But what it means is that, yes, there is structure, water structure, as Gilbert Ling surmised, but it was different from what he said. It was not just a stack of water molecules that were lined up, because you can take a stack of water molecules and lined up from here to the moon, and you'll never get negative charge because the water molecules are neutral. But this is negatively charged and battery-like.
Hmm.
So next question that arose, well, you can't create a battery out of nothing. You need energy to do that. It's like your cell phone. You go to sleep at night, you forget to plug it in. In the morning, you've got no cell phone that's operating. And so all batteries need charging, either to create them or to maintain their vibrancy. Uh, and so again, I couldn't figure out, or we couldn't figure out, where does the energy come from? You can't take a chamber and plug it into a receptacle in the wall. That's absurd. So where else could it come from? And we found, I should say, we didn't find, an undergraduate student, maybe 18 years old, found by accident that it came from light. So he was doing an experiment similar to what I described that we began doing, and he was standing at the bench, not sitting, standing. And I don't know whether he got bored or intrigued, but there was a lamp, a gooseneck lamp that was sitting next to him, and he shined the lamp on the chamber. And what he saw was that the exclusion zone, where the region that was illuminated, the exclusion zone grew, and it grew by leaps and bounds. It was really really major with that light. And so he called me in. I looked, and I was amazed because it seemed that he found that this was governed by light. And that's not so strange, because the same thing happens in photosynthesis. The first step in a long chain of steps involves light. For example, green plants, the light is incident on the green plants. And step one is the splitting of water into plus and minus. So it was not really a surprise to find that. But I might just interject a point about photosynthesis and the first step, photosynthesis. If a water molecule is broken into plus and minus, we learned that plus and minus are attracting one another, and so it's hard to understand how plus and minus could be separated from one another. And as far as I know, this question has not been addressed by the photosynthesis community. But we found an answer to it if what we found is similar to the first step in photosynthesis. And that is, I mentioned you've got a region of negative charge, the EZ, and beyond that, you've got positive charge. And of course, the positive wants desperately to interact with the negative, to come together. But it can't do it from what we found, because we found what the structure of the EZ is. And the structure of the EZ is a series of sheets, each sheet parallel to the nucleating surface, like the gel, for example. So you've got one sheet and next sheet and next sheet and so on. And they built actually up to, we found hundreds of thousands of sheets. Amazing. But the sheet structure is actually not as Gilbert thought, but the sheet structure is a honeycomb, a series of hexagons. And the openings of those hexagons are too small to allow the positively charged hydronium ions to enter. So the negative remains separated from the positive. And that, I think, is the key, because otherwise, plus and minus, like two lovers, they want to come together, and they can't because of this issue. So that, I'm hesitant to give a speech. I'd rather answer your questions, but that's an essential point of what we found, that the water, originally starting with water and from light energy, which we found, by the way, to be infrared energy in subsequent experiments, mostly not visible, not ultraviolet, but infrared energy. And it's all around us. It's not just the sun. Everything radiates infrared energy, and that's why the excuse me, the military uses an infrared camera to see what's going on with the enemy because the enemy's ammunition and whatever is generating infrared energy, which you can pick up. So it's that infrared energy we found that creates the battery, the charge separation, and this can be used, can and is used by biology and beyond. So maybe I should stop there and let
Oh,
you
I love
ask.
it. You can give a lecture all day long. This is beautiful, and
Oh,
I'm just
thank you.
curious. So you discover Gilbert Ling's work, and he's written off as a crackpot. I just wanted to ask: were you in communication with him along this journey, and letting him know that you were working on it, or were you guys talking to each other during this path?
Um, Glad you asked that question. So yes, and when my book came out, the one I told you about, um, it's called "Cells, Gels, and the Engines of Life."
Hmm.
Uh, we were in communication, and when it came out, he hated it. Absolutely hated it. He told me that I didn't quote him enough, and I think he wanted to me to quote him in every paragraph. But I made it absolutely clear, and I think clear to any reader, that this was not my idea. This is his original work. And of course, I mentioned his name many places, but not enough.
Hmm.
And also, when I communicated that that this is gel-like, he didn't like that at all. So one day he wrote me an email telling me how much he hated um, my work, and sent a CC to everybody he knew who was in the field of water. We became enemies, and I don't like enemies. And I worked for 10 years to try to recruit him back uh, into the fold, so to speak. And I think the real underlying underlying issue was I stole his thunder. Uh, my book, it became moderately popular, and not like the more recent book, which is amazing. Sometimes I have to pinch myself to look at the reviews on Amazon, uh, for example. Um, but that one, received some acclaim, not that much acclaim, and his stuff didn't receive that much acclaim because, as I mentioned, he his writing tends to be rather obscure and meant for the super expert in physical chemistry, not the ordinary expert. so so we but finally, I really tried hard to recruit him back into being friends, colleagues. Why not? You've got two people who are essentially espousing the same idea, and by giving him absolute credit, not him, it was not me, it was him. But he didn't see it that way. So finally, it was 10 years later, and it was at a conference that I organized and invited him. And he was sitting in the audience, and I presented evidence for long range order. And he stood up and he said, "This is amazing. I love it," and blah, blah, blah. And from then on, we became, uh, well, at least friendly colleagues. But Gilbert was not an easy guy. He told me stories of that he'd be at a conference, and at some of these conferences in large hotels, the meeting takes place, or in hotels with large conferences, large audiences. They have these ballrooms with a practically infinite number of doors you can enter or exit. So he told me he'd enter in one door, and the opposite door somebody else would enter, and they saw him, and they made a U-turn and exited. They didn't want to didn't want to deal with him. So he had the habit, which you may surmise afflicts me as well, because I've been talking, talking, talking. Uh, he had the habit of not listening but talking. So I remember an amusing story about a friend of mine who was in the muscle contraction field, but knew about Gilbert Ling's work. And this guy would talk endlessly. He had that habit about him. And he was telling me he went to see Gilbert Ling. And so he introduced himself to Gilbert, and then Gilbert started talking, and he talked for 2 hours. And my friend, who likes to talk, uh, said nothing, just listened and listened and listened. Uh, and at the end, Gilbert looks at his watch. Oh, I have another appointment. It's been such a delight to chat with you, Dr. Elliot. And Elliot said not a word. so so Gilbert, I think there are quite a few people who have ideas, and they like to talk about their ideas. And I guess I'm not immune from that. But Gilbert was pretty extreme, and so he had a lot of enemies, not friends. And I think that's a reason why he failed to win a Nobel Prize, which he absolutely deserved. But not an easy guy, a genius, but not an easy guy. So
Yeah.
anyway, uh, I hope
Well,
that
and you
answers your
you seem a
question.
lot easier from what I gather to talk to, and every time I listen to you speak, I think what a disarming character you are as far as presenting your ideas and being able to synthesize very complex ideas and give them to the average person, which is awesome. And I'm just
Thank
wondering
you.
how much pushback and what are the major points that people push back on you on with your ideas? Because I've heard that people try to discredit you and
Of
write you
course,
off as a crackpot, of course,
of
because you're a
course.
paradigm pusher, and then we can get into some of the politics of science and the reasons why these ideas are so profound and easily pushed back on.
Throughout um, the history of science, anybody who comes up with new ideas will suffer pushback. You know, uh, it was about 500 years ago that this guy uh, Bruno, Italian guy, he was espousing the ideas of Copernicus, that the sun was the center of the solar system, not the Earth. And the Catholic Church didn't like that. They thought they felt comfortable with the idea that the Earth was the center of the solar system, and they took retribution. They cut off his tongue so he wouldn't espouse heresy. They stripped him naked and they burned him at the stake, and then threw his ashes in the river. That was 500 years ago, and we don't suffer that way anymore. But um, almost without exception, anybody who challenges the status quo in a major way will suffer. And another guy who's less famous, maybe a guy named Semmelweis. You know about him. So Semmelweis was a Hungarian who got into a position at the most distinguished hospital in all of Europe. Was in Vienna. And when he came there, he was appointed to the obstetrics ward, and he noticed something. He noticed that the women who came in about to deliver, they underwent triage, and half of them, well, I'm not sure if it's half, uh, went to the midwives for delivery, and half of them went to the physicians. And the ones who went to the midwives did fine, and the ones who went to the physicians often came out in coffins. You know, so so he obviously he noticed this, and he was curious. This was before Pasteur, before anybody knew about bacteria and other viruses and what have you. And he examined the routine of the doctors, and because so many people died, uh, the first thing they did in the morning when they started is they did autopsies on the women who died, tried to figure out what was going on. And then immediately afterward, they did internal exams on the women who were about to deliver. And many of them obviously died. And he thought, well, maybe if they wash their hands before doing that, uh, it might turn out differently. Um, and so he did that himself, and it turned out that the women did just fine under his care, but not the other doctors. So he brought the idea of washing hands pre-Pasteur um, to his colleagues, his esteemed colleagues, in the so-called best hospital in all of Europe, in Vienna, and they rejected him. Why did they reject him? Because of their egos. How could it be that this upstart would come and determine that everything they did every day was wrong? And so they dispatched him to an insane asylum where he soon died. And so now there's a medical school it's named Semmelweis University, and it so happens that my former student is the dean there, so I know the place very very well. But that's the second example. Semmelweis wasn't burned at the stake, but he suffered. And then even more recently, there's Jacques Benveniste, um, and Jacques, whom I knew reasonably well. He showed that water had memory. So there was a specific reaction that he was studying that took place, and he found, or someone demonstrated to him, and then he took up this idea that if you dilute it and dilute it and dilute it, the way homeopaths do, and you wound up with essentially pure water. The pure water, or the so-called pure water, could do exactly what the original solution was able to do. So he said the water must have some memory of the original agent, otherwise it couldn't work. And he ran into a lot of trouble. He tried to publish his paper in Nature, in the journal Nature, and the editor, who was kind of had a reputation for putting down ideas that challenged the mainstream, um, he didn't want to publish it, and the homeopaths in Paris, where Benveniste was working, the homeopaths said, "Oh, this distinguished scientist," and he was. Demonstrated that what we do every day is really scientifically based. Uh, um, and so the Nature editor felt a lot of pressure, right across the English Channel in London, and he made a deal with Benveniste, and Jacques, when I visited him, pointed out it was this telephone right there. I got a call from John Maddox, and he said, "I'm going to make a deal with you," because Maddox felt under pressure. He said, "I'll publish your report in Nature next week. If you agree that we'll have a committee of peers to come and look over your shoulder to see what you're doing, and then report back to our readers." So, feeling a sense of this guy is sincere about doing that, he accepted. They came a few weeks later, and the committee consisted of three people. One was the editor himself, John Maddox. The second one was a guy named Walter Stewart, who was in the NIH had appointed a new section called the Center for Scientific Integrity. In other words, he was a sleuth looking for something underhanded. So he was the second one, and the third one was the most interesting. It was the amazing Randi. That's James Randi, a magician, famous for detecting the tricks of other magicians. So, for example, he was able to show that Uri Geller, the guy who said he could levitate, he found out, or he claims to have found out his trick. Whether he's right or not, I'm not sure. So it was obviously not a committee of peers exactly. It was a committee that was destined to show that this is a problem. Anyway, long story short, they reported, even though the experiments mostly worked, and Benveniste, when they finally published their paper, he said it doesn't always work. It works almost all the time. So when the French did the dilutions and the test, it all came out fine. And when the French did it, it didn't come out fine. And so they huddled and they determined that it must be a trick, even though the most famous magician couldn't figure out the trick. So Jacques' career ended there. And he became despondent. He couldn't get a grant. couldn't do his work, and eventually he succumbed. And so, I'm prefacing the response to your question by saying that in the history of science, uh, it's for the past 500 years, it's been the case that if somebody comes up with an idea that challenges the status quo, um, they're going to be attacked. And it was the great famous Nobel laureate Albert St. Georgi who discovered vitamin C, got a Nobel Prize for that, and is generally known as one of the most creative scientists ever. He said, it was only when my idea received polarized feedback, some positive, some negative, that I knew I was onto something, because there will always be people who feel threatened by it.
Mm-hmm.
So, my own case, uh, I suffered in my own academic department to begin with, because there are people in my department who are espousing or teaching the standard view. They didn't like the work that I was doing, and in many ways, which I don't need to discuss, they made life difficult for me in the department. So, but anyway, I needn't go into detail about that. But there have been some formal papers, maybe 4 or 5 or something like this, that attempted to describe why what we were doing, our interpretation was erroneous. The first one came from a guy in my own university, and we had sat down to discuss our stuff over coffee a number of times, and it struck me that he really wasn't interested in hearing my opinion or justification. It seemed to me that he was most interested in demonstrating how knowledgeable and smart he was. And after a few sessions of that, I said to him, "Hey, maybe we just have to agree to disagree." Well, 2 years later, I received an email from him saying, "Well, I didn't quote our conversations in this paper, and you probably won't like what I've written, but I'm sending it to you anyway." So he sent me his paper, and there were 2 of them, and each one was more than 100 pages long, and I couldn't believe how much time this guy must have has spent to put them together. And he talked mostly about um, Naphion, which is one of the hydrophilic surfaces that we used. Um, and he went on to describe how various features of Naphion specifically could give rise to what we found. Um, I found a number of obvious inconsistencies, and I wrote about that. But more than that, Naphion is only one of perhaps 50 different surfaces that we use that give the same result. So you can say there are special properties of Naphion that maybe give some strange result, but do all 50 of these, ranging over the gamut from biological surfaces to polymers to gels and all. And so this was the main one, and I, I've got to tell you that there was one reviewer who I know, and he contacted me. He said, "What do you think of this manuscript?" I said, "No comment. It's up to you to decide whether." He told me he found flaws, and he turned down the manuscript. He also told me he was the only reviewer, yet the editor decided to publish it. So it got published, and I did write a response. And then 4 or 5 other people chimed in, wrote papers, essentially, not completely, but essentially declaring that this guy was right. So that's the pushback that I've received. On the other hand, the number of people who like what we found, and and who are actually adopting it and using it in their work, their ideas, it keeps increasing, and it's kind of going like this, especially among people interested in alternative medicine. Uh, I'm a little afraid to say they love it, but the feedback that I get is so positive from so many people. And in fact, I get practically every day, I get one or two emails saying, "Hey, I love your work, and I've got 8 questions." It drives me a little crazy because I don't have time, and I'm not sure what to do about it. But I try to answer every email. I'm reaching the point where I'm not sure I can continue to do that. And so, yes, I'm sorry. Long response to your short question. There has been pushback. Pushback is expected. If I receive no pushback, it would mean that what we've done is insignificant.
Right. And what are some of the implications from your work that these people are constantly writing you emails for, especially for the health and wellness and holistic healing, um,
All over
potential
the place.
zone,
I,
everything?
I can't summarize because each
Yeah.
one differs, and um, they will speak about a particular issue that is sometimes a really minor issue or something
Hmm.
we never addressed, something that I think I know the answer, but in many cases I write back and say, "I'm sorry, we never studied this. I haven't thought about it. I don't know the answer." Um, so there's nothing. There's not a particular theme that
Yeah.
people write about.
So some of the big behavior shifts that people can make once they understand the implications of your work is I've heard you speak to sauna use because the heat and it starts to give that potentiality for the water to change and to maybe even increase your ability to have better health. I've heard you speak to grounding or walking on grass or near the beach on sand. Is that right? Like, what are
Yes,
some of these best behavioral shifts, and even what water should people drink? Because I've heard of hydrogen water, I've heard of deuterium depleted water, and I'm wondering what people can do with your work on a fundamental practical level that would be most beneficial.
good question. Okay. So the underlying theme, basic theme, is all cells are healthy cells are filled with easy water, and there's a lot of evidence to support that. But if for whatever reason, if your cell, like a muscle cell, for example, if it's short of easy water, it can't undergo the transition that I was talking about earlier. And what you want to do to bring the either pathological or dysfunctional cell back to normal is you got to build EZ. This is the central common theme. You must be filled with easy water for your cells to function properly. For each cell needs to be filled. So the strategy is what can you do to build easy water? And often I'll list half dozen expedients that are not so difficult, including the ones you mentioned. And so, for example, for a sauna, or as the Finns say, sauna, um, what does that do? Well, it's heat, and heat is producing infrared energy. The two are almost synonymous, not exactly, but and so you take off your clothes, you expose your entire body to infrared energy. The infrared energy penetrates your body, even your skull. Um, um, there's clear evidence for that. And what does it do? It builds easy water. We know that from our experiments. So I think that's the reason why you enjoy a sauna, or the Russians say banya, almost the same. You come out of there after 20, 30 minutes and you feel better. If you have pains, the pains are reduced or eliminated. If you've got a headache, it's gone. If you feel tired, you can feel energetic again, etc. It's the central underlying theme is building easy water. It's like going out in the sun and exposing yourself. The sun is roughly 50% infrared energy, um, and you're exposing yourself. And the reason you feel good when you walk out into the day has been, or the week has been cloudy, and suddenly the sun pops out, you feel good. And many people consider that to be a kind of psychological effect, and perhaps it is. But I'm thinking that the sun penetrates your skull, goes to your brain, and your brain cells then are the amount of easy water in those cells is amplified, and so you feel normal again. You were born not depressed or unhappy. You're basically born happy. So you're brought back to that. So that's one expedient. Another expedient is drinking water. So when you drink water, we all know that we need to be properly hydrated. But what does that mean exactly, properly hydrated? Well, when the cell is hydrated, it's full of easy water. And the water that you drink, some of that water gets peed out or evaporated, sweat, but some of it gets converted into easy water. And we found, indeed, in the laboratory, we could take water and through an electrode passing negative charge or electrons, that water, liquid water, turns into easy water. So it's not just being next to a hydrophilic surface and being exposed to infrared, but just passing electrons into the water does the same. And so that actually leads to the idea of walking barefoot on the beach near the ocean. Why do you feel good? Well, you feel good, I think, because the earth is negatively charged. And I didn't know. I began my career studying electrical engineering, and no professor even hinted that the earth was anything different from neutral. You stick a plug into the wall receptacle, and that third prong is connected to an infinite sea of negative charge. But I heard nothing about this when I studied. No professor even hinted about that. And then one of my students, after I learned of this from a Russian guy who was working in my lab, who tells me, every Russian student educated at the time he was, middle school students, know that the earth is negatively charged. I said, I never heard of such a thing. He said, well, I think the American educational system is a little bit deficient. And I think he's right. I did confirm with some Russians of contemporary age. Yes, they learned that. They don't learn it anymore, but they learned it. And we've forgotten it as well. But the next day, after this Russian colleague told me of this, one of my students brought me Feynman lectures, the famous Nobel laureate, considered by many to be the Einstein of the second half of the last century. Volume 2, Chapter 9 of his series of 3 books of Feynman lectures. It's all full of evidence that the earth is negatively charged. It's just that we've forgotten it. It doesn't mean it's not true or not true anymore. It's just forgotten. So if you take off your shoes, because the shoes are insulators mostly, except a few modern incarnations which are built of conductive material, so you can actually connect to the earth. You walk on the earth with feet that are conducting, either that or bathe yourself in the ocean or a mud bath or so walk on wet grass. The effect is more or less the same. You're connected to a vast sea of negative charge. Negative charge builds easy water. And so I think this is a straightforward reason why you feel better after you've done what I've just mentioned. So those are a couple of expedients that can be used to feel better. There are a few more. I could talk about them. I'm not sure whether you'd like me to, or go on to another subject,
Yeah, maybe
whatever.
just briefly touch on juicing and hyperbaric chambers, because I know
Yeah,
that the hyperbaric chamber, it made sense to me. Like if you're outside and you're in the sun and you're on the grass or you're on the earth, in the sand, wherever you're at, and you're grounding in that way, doing breath work, which can change your blood chemistry in certain ways. You can become alkaline if you want, or you can do certain methodologies that ancient yogis would do forever to build the CO2 tolerance up. And you can sort of become the alchemist in a certain way by also placing yourself in the right environment and using blood chemical techniques, which is breath work. And it's same as hyperbaric chambers. So I just wanted to get a little bit into those two, and then we can go on a little
sure.
further.
Okay. Well, maybe it's sort of similar, but the two features of hyperbaric chambers is high oxygen, um, and high pressure. Um, that basically defines hyperbaric oxygen chambers. So we did studies and we published them. We looked at high oxygen to start with, and we found that if you change the oxygen from the normal levels to a higher level, you get more. The EZ grows more; it gets bigger. Um, and if you do the same thing with pressure, if you go from normal atmospheric pressure to a higher pressure, EZ grows as well. When you combine higher oxygen and higher pressure, you're basically doing what you can to build EZ water. And I've experienced hyperbaric oxygen chambers myself for various ills, and so did my late wife. Um, and it seems to work. It seems to work for numerous syndromes. It started as chambers that were used for healing of wounds, military wounds that wouldn't heal. Put put the guy in the hyperbaric chamber a few times, and it's like magic; it healed. Uh, and right now, there are my former student who worked for a company that was researching. He said there are 29 different syndromes for which hyperbaric oxygen is useful. And so a possibility is that it's so broadly useful, and it's broadly useful because it's a good way of building easy water. That was the first one. What was the second one that you mentioned?
Juicing. I remember you saying
Juicing,
that
yeah.
just taking
Okay,
raw material. Yeah.
yeah. So this is something my late wife used to do in our backyard. We have a nice backyard, and um, growing some vegetables, and she'd go out. She'd take some new, freshly grown green plants, harvest them, and put it in a machine that basically squeezes the hell out of them. And it basically squeezes the juice, and you drink the juice. Now, what is this juice that you're drinking? It's the water from inside the plant cells, and these are freshly grown plant cells, like young babies. And what you're squeezing out is basically easy water because the plant cells are filled with easy water. So if you drink this stuff, you're drinking easy water. And so if drinking easy water means that some of this easy water will come and fill your cells. And so that's why various people have touted juicing as the best thing you can do. Simple, well, for people who have some time, simple to promote health. And so I think a lot of people are beginning to do that now, understanding that there's something to it. And so, yes, I hope that answers your
Yeah.
question.
Absolutely, thank you. And I'd love to get into some of like Robert Becker's work, and I don't know if you've ever got into Andrew Marino's work and his book Going Somewhere. It's a really cool book about science and some of the politics of science. But anyway, it's really about the EMFs, the electromagnetic fields, and the exposure that we have, and how that probably affects us. Obviously, if we're all water and we're trying to get easy water in our biochemistry, how much exposure we have now to blue light and to be in these false lit environments. And we've stripped away all of the good lighting, which is why I talked to Zimmerman about actually putting back in old bulbs, the old incandescent bulbs, where you're getting more of the right spectrums of light indoors because we're inside so much, which would create more easy water. And
Yeah.
obviously trying to get outside more often. But then how much do you think the grid is having an effect on us, and also just being exposed to the wrong lighting all the time for our health?
Um, I can't give a number, but I must say that I've been impressed by a few things. One of them is the book by Arthur Furstenberg called "The Invisible Rainbow," and um, and he documents in this book for over a period of 100 years that anytime there was an advance in electrification, uh, uh, the incidence of disease, especially cancer, would increase. And it would persist for a year or two and then level out. He gives so much evidence for this that it's hard to discount it. And the one I remember the most is that in rural America, it wasn't not all places were electrified until around the 1930s. And he documents how as soon as a city or a region was electrified, the incidence of cancer went up precipitously every time. So and many other pieces of research that he documents exhaustively. It's almost encyclopedic to read, but you know, it's really powerful. So that book for some people has become a kind of Bible, and and we got interested in this, and so I had a student work on this. We put a router next to our chamber in which we measured easy water. The thought being that if easy water is really so important, maybe the mechanism by which the EMF or some of these EMFs cause problems is by reduction of the easy water. And I had a student who was working on it, and the student found indeed that was the case. He put a router next to the experimental chamber, and when he turned on the router, the easy size diminished by about 20%. We've not published it, and I'm not sure we're going to publish it because I can't find a student anymore. I mean, he was like one of the world's friendliest students, and I appreciate what he did, and we went over his results again and again, and he suddenly disappeared, and I haven't been able to contact him since, nor has a colleague of mine who was close to him. So we don't know what's happened to the student, and I feel uneasy about publishing something where the person who did the experiment is not cooperating in any way. Anyway, the experiment needs to be repeated. It was our attempt in looking at these EMFs, especially 5G and such. It's There's been a lot of talk about it. That's the extent to which our own experiments have been done. I think it's
Mm.
desperately needed, and of course, put down by the powers that be. Um, there's
Yeah.
always a conflict, as you know, especially big pharma and such, and uh,
And the amount of
Monsanto.
money, I guess, that goes into the power grid, and there's so much vested interest that people repress it. I think Andrew Marino testified in the 70s
Oh,
about the effects of grid on mice and on biology and how negative it was happening for cancers and these things. And um, I think
I'm not
Becker,
surprised.
yeah,
I'm not
Becker had a
familiar with that, but I'm not
yeah,
surprised.
and Becker was pretty famous scientist himself, and who his reputation was destroyed after he started to come forth with his information. So it's really interesting how it's sad actually, because people come forth with things that would actually benefit our health, but because of incentives for different companies and different reasons, it gets repressed, and then people like your friend maybe either get threatened or coerced, or they ruin reputations. There's a million ways to repress good science.
Well, that may be changing with the new administration, and if RFK is somehow approved by the Senate, things will definitely change because he's definitely interested in finding truth, and his truth is of course disparaged by a lot of people, but there's a lot of evidence underlying it, and he keeps winning court battles with juries. And you don't win court battles with unanimous juries unless you really got something there. So we'll see what
Yeah.
happens, and I'm
Yeah.
I'm optimistic that things might change. We'll see.
Yeah. I'm excited about it. I hope it comes forth because he knows the underlying issue better than anyone, obviously with family
I think
members
he
being
does. He's been
executed
criticized
and
because, he's not a medical doctor and therefore he doesn't have the educational credentials. But boy,
right.
he really knows what's going on.
Yeah. Yeah, because I'd love to know what the effects of all these new measurement devices between watches and aura rings and all these things that people use to measure their physiology. It's like that could actually be causing more harm than we know as well. And it would be nice just to know and have people measure
I've,
it.
I've had the same thoughts myself. Um, but, I have relatives and friends who use these devices, and sometimes it's a little awkward to mention that. Um,
Yeah.
yeah.
Yep. So I'm curious. I think I've heard you mention quite a bit about Gilbert Ling. I also did, but it's basically like prayer and intention and positive affirmations around water and watching the change that happens. Also, music and things of that nature, like the secret life of plants. And you start to realize that plants have intelligence and that there's something happening in this domain when it comes to, you could consider it just being the first part of easy water, I guess.
Well, funny thing you mentioned, I just had a telephone chat just before this with Federico Fagin. And you may not know the name, but computer science people know that name. He invented the microprocessor. And now he has a foundation. He's helping to fund us. As you can imagine, he, the invention of the microprocessor led to uh, immense wealth. And Federico, um, um, he gave a sort of a biological talk that I heard, and he said after he made an enormous amount of money and became famous in the computer science field, he felt empty. He hadn't really contributed, and he got into consciousness, and he's been doing that. And he was telling me on the telephone how his latest books are bestsellers in this area, and he has his own views on how things actually work. Really interesting
Mm.
guy. And so we actually began studying this in our lab, and what we have done and are still doing. For example, we take a container of water and we invite a healer. Um, uh, uh, to someone who's a recognized healer to put their intentions to the water. And we measure the physical chemical properties of water before and after using standard techniques. And we were at it for a while. And finally, we got a positive result after we refined the technique that we use. And we're writing it up for publication for actually a couple of different schemes, shall we say, one with healers and one with a healer. His name is Bill Bankston, who, through consciousness, sometimes is able to cure cancer. And his work with mice, for example, almost 100% effective. And he does it with people too, with effectiveness. But it's always possible to say that the people had a certain point of view, and they're cured because of that, rather than through what he's been doing, and that's the reason for the initial focus on mice. So these mice are injected with a mammary tumor, um, and and um, 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 and it's 100% lethal. The tumor grows and squeezes out all the other organs, and within, I think it's 35 days or so after injection, um, the 100% of the mice uh, uh, have perished. So what he does is he takes a cage full of these mice that had been injected and have tumors. A cage full, puts the cage on his lap with the mice inside, puts his hands around the cage, and goes through a series of thinking. And the thinking is mostly positive images that he sees. So, for example, I'm inventing this, but for example, he might be winning a Nobel Prize and shaking hands with with the King of Sweden. So he'd have a portrait of that, and he would visualize the portrait, and then go on to another portrait and another. He'd go through 20 and then recycle and go through. And I'm not sure how much time he puts in. I have the sense, he's reported it, but I forget. I have the sense as an hour or two. He says it's boring. And 100%, all close to 100% of the mice are cured. And not only are they
Wow.
cured, but they become immune. So they get injected again. And the second injection, they have no response, no cancer develops.
That's
Uh,
amazing because that
isn't it
defeats
amazing?
the,
Yeah.
it makes it to go away from, I was thinking initially it was the placebo effect, which is still a phenomena where you're like, okay, the power of belief, if you think you're going to get better, or maybe even gratitude or appreciation, these types of inner not mantras. But if it's mice and they have someone else doing the visualization for healing, that's really powerful.
Well, that's what I thought too, and that's why we got so interested. And he's provided us samples of water, essentially, that's been through this procedure, and it looks like there's a positive result in our test. So we've got two of these tests going, and the results are positive enough that we're writing up the results. So I think you're right on. There's no placebo effect, I guess, with mice. Maybe there's something we don't understand, but yeah, I think this
Mm.
in the future, this consciousness idea is actually taking hold. Quite a few people are beginning to pay attention to it, and I think this is the frontier of the future. That
That's amazing. Yeah,
Yeah,
because a lot of traditions like Zen Buddhists and monks, they believe that if you sit on the hill and you meditate and you imagine peace in the world, that you're actually producing peace. And it would be so cool to see these studies go further because I used to use the float tanks a lot back when I was 30 years old, and I was in the tank, and my whole orientation in a meditation is to not focus on something, which is, I'm finding this fascinating, but I would more let go and get out of the way and just see what
yeah,
emerged.
yeah.
But after a while, I started to experiment with the ideas of, man, if I can start to focus my mind on healing myself, maybe I can. And I started to get my low back injury better by using my own mind. And I couldn't write this up in a scientific report because it was my own self experimentation. But my low back injury that I supposedly needed surgery for healed from doing this type of work. So then I started to reverse engineer and study and find out who else has been looking into this. And that's when I discovered a lot of different people, even people like Rupert Sheldrake with the morphic fields. And there's just a lot of people out there who are studying consciousness. And I think it is the great mystery. It is the thing that is so hard to pin down and to prove, but there's so much, thousands of years of people talking about different ways to use the mind body connection and to heal and to do other things, even the imagination to our belief systems. It's like, what is the imagination? It's still a great mystery. So there's a lot to explore when it comes to
I fully
consciousness.
fully agree with you. I visited the university in, I think it's Iowa, a transcendental meditation university, and they've been actually doing scientific studies on this. They gather together meditators, and when you get a critical number of meditators, it has an impact on the community around you. And they study that and have published work on it. It really works. And I remember there was one study that was done in Israel maybe 20 years ago, where there was a lot of hostility and uh, uh, explosions, um, uh, and they announced ahead of time that they were going there in large number, and they're going to reduce the amount of number of incidents of aggression and immolation and self destruction and crime and all that. And so I saw the result. They plotted as a function of time. They plotted the number of people meditating. So they went there. I think it was January 1st. They said they were going to come for 1 month, and they plotted the number of meditators. It was not always, not everybody's meditating all the time. They like to go see the sights and such. So the plot of number of people meditating looked like a square wave with a lot of bumps and whatever. And they then next to it, they plotted the number of incidents of serious crime incidents as reported in the newspaper. Um, and it was a mirror image. It was incredible to see
Wow.
even those little bumps on the top were reflected in the number of incidents. They had a hard time publishing, but they published, and they've done other studies like that. Um, and then
That's
I also
amazing.
remember the book by what's her name, uh, Lynn, Lynn McTaggart. No, The Power of Eight. Maybe you've seen that.
Mm-mm.
So she she's interested in these kinds of subjects, the power of eight, and she did her own study on how many people you need to have such an effect. And it turned out that you don't need a few hundred. For example, praying at the same time, you could reduce the number to actually eight. Eight was the critical number. So you've got eight people putting their intention toward healing, and it works. That's what she demonstrated. And I remember my wife, who was going downhill with ovarian cancer. We had one of these sessions every week, and she eventually passed. But I think that the suffering was much less than would have been the case otherwise. At least the hospice person said that, or said that she's suffering less than
Mm.
most others. So so um, it seems if she's right, you need only eight people together to do the job, but usually larger numbers of people. And she also showed in the book, interesting book, she said that the healers themselves, the eight people, uh, received a positive result from this. They also were healed, not
Mm.
just the subject of the healing. So it's a pretty interesting book, and there's now so much information on this, historical information that you mentioned, and contemporary information. I organize the annual conference on the physics, chemistry, and biology of water. It happened. It happened a few weeks ago in Lisbon, where I happened to suffer the theft of my computer, unfortunately. But at any rate, um, and each year there are one or two or three people presenting information or studies, reports on consciousness in one sort or another. So it's real. It's going on. People may deny it, but there's enough evidence to say that it's true. But the mechanism remains a total mystery. It's the
Yeah, yeah.
future.
And then it's also making me think too to not forget about the implications of negative beliefs and negative thought patterns. So, like if you're sitting there and you're feeling victimized or you're feeling depressed, the worst thing you could possibly do is to ruminate and to circle into those thought patterns for your own health, or to even
Absolutely.
do that to other people, like to project these ideas about the world. So, just really starting to realize that it is a mystery. There are some scientific research entities doing stuff for us to start to reverse engineer and see maybe this does have power. But all of the ancient philosophers and throughout history, there's been a lot to say about this, about the power of prayer and the power of belief. So it's like, just be careful. If we don't know, we should explore it timidly instead of acting so righteous like we know what's going on. And then it's like, well, maybe we get outside more, get some sun, get some more elements of nature, and get outside as the number one premise and start to focus on what our thought patterns are as a really good place to start.
Well, yeah. I mean, what you're saying is anathema to the scientific community because most scientists are not open to that. Most scientists feel comfortable with a body of knowledge that they've learned and they've espoused and whatever, and they're not open to new ideas. You can imagine. Imagine 200 years ago, the idea of electromagnetic energy. Nobody ever heard of it, and someone coming forth with this idea, it gets rejected. Anything that's new, you might think of it as a kind of surprise, but it's human nature. We have egos. We like to protect our egos. We think we're experts at a certain within a certain sphere of knowledge, and we don't like to be challenged. We like to feel that we know what there is to know, and this is a problem, and it's a problem faced by the granting agencies that grant money to allow you to explore. Um, um, the people who do the reviewing are those people I'm talking about who have not all, but have a tendency to protect the status quo, which means no change. Uh, so this is a serious issue, and consciousness is, I think, in among that. Unless you're dealing with agencies that are particularly involved in that, and there are a few, um, getting money from government agencies to do something like that is virtually impossible. Even I hate to mention this, but the National Institutes of Health (NIH), I have the sense that the word water is missing from their dictionary. There's, if you assert that water might be more interesting than you think, um, it's almost impossible to get a grant because the reviewer uh, needs to review all the evidence, and they're not aware of the evidence, and so the amount of time they need to devote to learning about it is simply not available. Everybody's too busy, so it
Yeah.
means you submit a grant proposal dealing with water, and um, it's almost, I wouldn't say impossible, but very difficult to get money from the usual granting agencies. And it's just that, and consciousness really does fall into that category. It sounds woo woo to most scientists. I'll
Yeah.
reject it until the rest of the world is convinced that there's something to it.
Yeah. That's why we need more of a decentralized model for sure to get outside of these institutions that are captured by the funding and by the reputation grabbing and all of the stuff that goes on inside of these
When you
political
say
systems.
decentralized, what do you mean by that exactly?
Just getting away from this institutionalized model of learning and
Oh,
of exploring. So even the money, the capture of money. So Bitcoin would be a decentralized currency if
yeah.
you were to think of that. And that would be a huge component because the money flows, and that's where energy is coming from, really, to fund the ideas and the exchanges of information. And then getting outside of the capture. So, like during COVID, it was so easy for them to censor any keyword through algorithms that spoke about, say, ivermectin or any
Yeah.
alternative, even vitamin D was being repressed. And then anything negative, like you couldn't mention certain, you still can't. I had a podcast removed a month ago from Peter
Would
McCullough,
you?
who was a really well published doctor in his field of cardiology. And ever since the pandemic, he's been repressed and his reputation's been uh, somewhat destroyed to the best of their ability. And he's just trying to seek truth and to find the best way to treat patients and find the right outcomes. So it's interesting what's going on here.
It's, I'd say, shocking, but I mean, it's not shocking because understandable what they're doing, but it's a pity because science, typically you've got two points of view, opposing points of view. They argue it out, and you listen to the arguments. You can decide for yourself which one you think is right, which one is wrong. When they censor, um, then there's no argument anymore. It's just it's a product of censorship, and most people don't realize that the opposing point of view is being censored, so they're willing to accept uh, the point of view that the government, for example, likes to espouse, and if you say something opposite, you're considered to be a crackpot.
Hmm.
How could you believe this when everybody knows X Y Z? Um, and
That's why
that's
these podcasts are amazing platforms for even the past election to get RFK, who gives us a little bit of hope that things are on the right path. But podcasts and X from Elon buying X, which allowed information to get passed forth. I think podcasts are the medium of the future to have any presidential candidate to be exposed and to allow them to speak for a few hours at a time so we can see who these people actually are.
Yeah.
And RFK was out there on podcast platforms, and I knew who he was, I think, in 2019. And he was already speaking about a lot of the common issues that we're seeing amplified today. So I do have
Yeah,
hope, and
he's
I think we're on the right path.
absolutely, he's a really impressive guy. He was actually on the board of our startup company, so I got to know him a little bit. We had a board meeting at his home in Los Angeles, and we met in a room that was like a museum filled with Kennedy memorabilia, um, and
Wow,
I was seriously impressed. I must say, um,
that's amazing.
I think he's really in search of truth, and he's battered from all sides for it. How
Yeah.
is it possible that you can think that that vaccinations could be problematic? Uh, you know,
Mm,
well, there are issues.
yeah.
So yeah,
Yeah, it's going to be an interesting next few years for sure, but it's nice that we're here
if
for
he
it.
gets approved by the
If he gets
Congress,
approved. Yep.
he many of them consider him to be a crackpot and a villain or somewhere in between. Um, but I I don't take that point of view at all.
Yeah.
I think he could achieve. Many people consider the NIH and NSF examples that the rest of the world copies. I think to some extent that's true. If things change with those organizations, they're going to change throughout the world, and there might be a I don't know if to call it a renaissance or something like this in scientific thinking. I hope it happens.
Yeah. And even if he, for some reason, gets blocked, I think people, we got to see that with this election and the podcast world. And like you look at the numbers of a Sean Ryan or Joe Rogan podcast versus CNN or Fox or any of these old networks, those are dying off. And I feel like ideas want to be free. People want to be free, and we want to go forth in a different direction. Just a
Absolutely.
matter of how we're going to get there. But I think underlying that, the consciousness shift is the most important part. And I think it's there. I think people are really there.
I agree with you. I think so too. I see it. I pick it up. I go to more and more conferences, speaking at conferences where the main theme is consciousness. Um, yeah. Um,
Yeah, and that's the first thing to shift. And maybe if you can get out and get more sunshine and create more easy water in the biochemistry along with that shift, it really will be a paradigm shift to get back to nature, the fundamentals. I really think a lot of it's free, it's effective, it's easy. It doesn't require you to go to some $10,000 seminar or take all these expensive supplements. It's just simple stuff, but we just need to understand it and share that information and get people to make slight little tweaks in their behavior and their belief systems. And all of a sudden, you've got a healthier um, community of people.
Absolutely. I think you're right on, and I think we're at the cusp
Yeah,
of that metamorphosis. Yeah.
I agree.
Absolutely.
Well, I always have a question I ask everyone, and it's basically if you were going to die today, what would you want to share with the world?
Well, I've thought about that quite a lot. Um, um, and I guess there are two aspects. One is um, in general, and one is what I myself would like to share. And in general, it's an openness to fresh ideas. Uh, children have that, and the schools they inadvertently blot that out. So the people who are most successful um, in schooling are the people who can spout back what they're taught. In other words, we're taught the facts, and we receive rewards for accepting those facts and learning them properly. And those are the people who are at the top and they succeed. And in my view, that's not the best way. If I were running a university, or a scientific university, and I have had that in mind. The students who I would choose are not necessarily. I wouldn't exclude those people, but I would choose the people who like to go to their basements in the evening and do experiments, and want to learn what there is to learn themselves. Um, um, so that's a generality, a kind of take home message for me. We want to find the truth, and I think these are the people who can find the truth because they've demonstrated that they've been doing exactly that. Um, for me, um, my legacy is trying to find truth, and I've for some reason I'm not sure why, but I've been doing that all my life in the field of muscle contraction for more than 2 decades. Um, I was challenging the view of a quote great scientist unquote Sir Andrew Huxley, a member of the Huxley family, Nobel Prize, president of the Royal Society, master of Trinity College, Cambridge. Every accolade you can imagine. When the guy walked into the room, there was a hush. It was like God walked into the room. So his theory of muscle contraction. I don't know how to put this. It's simply wrong, and there's so much evidence. Yet, because of his distinction, there are many people who follow. Anyway, I did write a book long ago, 1990, on what I felt was why I felt his theory is absolutely it's wrong. It just doesn't fit at all, and coming up with a theory which I think better fits the evidence, and it's gone nowhere. But that's not really my worry. I understand that being in competition with a person of that distinction, inevitably you lose because most people want to follow the great Nobel laureate and be anointed by him and such, and that's the way the field goes. And I've been doing this ever since. We talked about the water issue. There's a lot more that's coming. The next book is coming out, I think, in January. I hope, and it deals with phenomena that we see every day. We think we understand, but we don't understand it. And I demonstrate that we don't understand it because if you penetrate beneath the surface just one layer, you come up with questions that you can't answer or that don't make sense. And I do this with multiple issues. I do it with questions like what turns the Earth every 24 hours? Um, um, is our idea about gravitation correct? One mass attracting another mass. How do you explain weather? How do you go from fundamental principles to hurricanes and thunderstorms and such? How do birds fly? How do airplanes fly? In fact, you'd be surprised. There was an article in Scientific American, and a friend sent it to me, and I was thrilled. It was written by two people who were chosen especially because they're the most prominent in understanding how planes fly. And the title of the article, it was something like "How Planes Fly," and the subtitle in smaller subtext or a smaller font size was, "Despite years of study, we still don't understand how planes fly." If you can imagine,
Wow.
the next time you get into the plane. Well, so I address this issue, and I have my own ideas about how planes fly and how birds fly, and the ideas that you may have, I believe, are not correct, and all of these, and how some sailboats can sail almost directly into the wind.
Hmm.
Boats, ice boats, just like sailboats, look like a sailboat, but they run on runners on ice, like ice skates. So very little friction. And they can go 100 miles an hour, and you feel the wind on your face. So if you feel the wind on your face, it's like I'm blowing on you and pushing you, and I'm doing that. You should go backwards, but you actually go forward. So something is wrong, and you need to be able to explain that. And how fish swim. Well, so I address all of these, and I'm saying this to give you an idea that for my legacy, what I would like to leave is a search for truth, and I, at least in the field of water, I hope I'm on the right track because the book, The Fourth Phase of Water, if you look at the reviews on Amazon, I'm a little bit embarrassed to say the current rating is 4.9 out of 5 stars. And I can't find many books that exceed that. So it's extraordinarily popular. And of course, I think we're onto something. And water forms the basis for a lot. And so does electrical charge, which I'm talking about in the book that I just mentioned. And I've got several other books in progress, almost done, waiting for my son, the artist, who took 3.5 years to remodel his home and took a break, so to speak. He's a gifted artist, and I will never choose another because he's just amazing and so easy to work with. So next book, which is just about ready for him to finish the artwork, is about the structure of the atom. I think it's
Cool.
wrong. I think what we've learned is not correct. And I present an alternative that I think is either true or closer to the truth. Um, and then another book, which is first drafted. I got some feedback from people in my lab. It deals with volcanoes and earthquakes. Nobody knows the energy that's required. I live in Seattle. Mount St. Helens blew its top about 40 years ago, and it's reduced significantly in size. And you can imagine the amount of energy that's required to do that. I think it's related to water in some way that I describe in the book. And finally, and that book is not so far from being finished. And then another book that I started working on is about cell biology. There are some features of cell biology that everybody knows is true, basic. What people don't know is that there's evidence against those points of view. And a lot of people just ignore the evidence and stick to the point of view. For example, energy. And everybody knows, quote unquote, that the energy comes from ATP, from a high energy phosphate bond. Well, several people studied this after a guy named Lippincott, a distinguished scientist, was espousing that view. I think it was 1941, a long time ago. And several different groups have addressed that, and they found no such high energy bond.
Hmm.
And nobody knows about it, about this, but the evidence has been ignored. Now, I don't know who's right. I don't know if it's the original finding or this new finding. No, I shouldn't say new because it's not really new, but it's existing in the literature. But nobody pays attention to the challenge. So we don't know whether the challenge is correct or the original finding is correct. And this has got to be addressed. And there are other issues like that, really fundamental issues that I talk about in this book that I'm just first drafting. So I'm saying all this. It's a long answer to your short question. And you probably didn't expect so much blah, blah, blah. But I'm interested in leaving a legacy involving a search for truth. I don't know if I found it, or I found it in a few instances or not, but that's my goal. And there's a lot more to be found, and it intrigues me no end.
I
I wish
love it
I had
because
more time.
you can tell you're so enthusiastic about it, and it seems like the underlying goal is to seek truth, not the overarching truth, but it's like it's constantly revealing itself. I remember Feynman saying that it's like an onion, or you're not finding the overarching truth, the end goal. It's like it might just get more interesting, and maybe nature reveals herself as this complex and infinite thing to keep exploring, but we should never think we have it figured out. And it's nice that you're a paradigm pusher and you seem to question authority and be a contrarian and go against what the hive is doing. And I think that's where we find new
Well,
ideas. And
those descriptions, I'm not sure that those are necessarily positive attributes, but I got to say that I'm interested in finding truth, and that's the legacy that I would like to leave.
yeah, I think those are positive attributes, and you're an
Well, thank
amazing
you.
human being. It would be cool to be in your head for a couple days and see what that's like.
Oh my goodness. I hope you avoid headaches.
And you do have a couple charities, I think, and you want to mention those real quick. I don't want to hold you up too long, but
Oh my goodness, we've been talking for a while. Yeah,
Yeah.
the Institute for Venture Science, ivscience.org, um, and the idea is to fund unconventional ideas, or ideas that challenge mainstream thinking, where mainstream thinking doesn't make sense anymore. And this has been going for a while, and the idea came from here, because it's so clear and so obvious that science should be open to fresh ideas. Fresh ideas should be seriously evaluated, not put down immediately. They need to be evaluated. Right now, typical response from the establishment is, "Oh, that guy proposing that idea, he's a crackpot. Pay no attention to it." And what can you say in response to that? "Oh, I'm not a crackpot. That doesn't work." And so the IVS has ways of dealing with those issues, and we depend on private funds, and we haven't been able to get a whole lot of private money. But we're hoping that will change in the future. And as I mentioned earlier, I'm hoping that some of the ideas that we've been developing and dwelling on now for close to a decade will be adopted by the new administration. I'm not sure, but I'm trying. That was the original idea, to get funded by the government, and I quickly learned that no, the government will not fund something like this. But with RFK Jr., it's possible. I'm not sure, because his goals are not so different from our goals. So yes, we have that in mind in this foundation that we have, charitable foundation. And if people are interested in supporting it, we'd love it. Supporting scientific endeavors is not cheap. That's the problem.
Mm-hmm.
We have some people who are donating like $20 a month, and while we appreciate that, it's not going to fund a major scientific enterprise. So we're working on it in as much time as I have. And the other thing, that it's not a foundation, but we publish a journal called Water, and there's no charge to people. We're not a money-making organization. We manage somehow to fund it through by hook or by crook, and it's going, and we're attracting more and more interesting articles about water. So that's a second one. I'm not sure there are any others. We run the annual conference on the physics, chemistry, and biology of water. It takes a good deal of my time each year to run it, but there's a lot of really interesting stuff, including a whole bunch on consciousness and water, because it seems that there are good evidence that the consciousness may lie in the water, which is 99% of our molecules. So yeah, we've got a lot of stuff going, and I wish the day in Seattle had 48 hours instead of 24 hours. This is problematic, but maybe you can achieve that.
Yeah, no, I've really appreciated the time you've given me and the audience today. It's really been an honor to talk to you. It's fun.
Oh, it's been my pleasure. My great pleasure. It's my favorite topic. So thank you for the opportunity. I appreciate that.
Absolutely. Thank you. Thank you for listening to the episode. Be sure to subscribe to the show on Spotify, YouTube, and iTunes, and rate the show. I hope you enjoyed the episode.
What we call reality is in fact nothing more than a culturally sanctioned and linguistically reinforced hallucination.